Hello everyone, my name is Matheus and I'm here to present my paper, which is entitled Behind the Intents, an in-depth empirical study on refactoring during code review. This paper was done in collaboration with many people. I'm currently an assistant professor and researcher at the University of Fortaleza in Brazil, and I have colleagues from PUC-Rio, UCL, and University of Salerno. We all know that code review is a widely employed practice in software development today. It's used both in open source and industry. There are open source tools to assist developers in performing code review, such as Gerrit, Crucible, and we also have open source platforms such as GitHub and GitLab, in which they employ a pull request based development that is very similar to code review. And also big companies such as Google, Facebook, Amazon, they all have their own proprietary tools to perform code review in a daily basis. But what is code review? Code review, in the code review practice, it's a quality assurance process in which source code changes are first reviewed by developers before they are introduced into the code. So, based on a certain repository, a developer, the author of the change, will take the original code base and make changes. Right? The developer will fix a bug, implement a new feature, refactoring the system, whatever. These changes are not going to be merged into the repo instantly. First, they're going to go through review, where all the developers will take a look at the code and provide feedback in form of comments, in which they criticize and make comments regarding that particular software change. The author will take this feedback and make a new revision of this change to be reviewed again. So this cycle repeats itself until both the author of the change and the reviewers are happy with that code change, and the approved revision is finally merged into the system. Now, this is MSR, right? So we all like to mine software data and learn from software data. However, the common approach for mining software data in specific software evolution, researchers commonly take a repository and they take the master branch of this repository and they consider each commit as a single data point for analysis. However, we know that developers use code review systems. They use code review practices. So when you're doing code review, when your development process uses code review, a commit is not a single data point. A commit is actually the final result of a series of revisions that have been produced, reviewed, commented, changed, and they finally made it into the master. So by looking at code review data, we as researchers, we have a whole bunch of information to study and to make it more interesting and have actually more information and more context for each software change than only looking at the commit. When we consider code review data, we have the entire evolution of that particular code change and not only the final commit. And this data set, I mean, the data that you get from code review is not only code. Every time a developer makes a new change, he or she has to describe that change in a description message, where he or she describes what has been done and why, and all the developers will make comments on those changes. And all of these descriptions and comments, they are in natural language. So now you have not only the complete evolution of a certain code change regarding the code, but you also have natural language descriptions and comments regarding that change. So you can see that this is a very rich source of data from which you can study and analyze software evolution. You can do studies on many things, from testing to all sorts of studies regarding software evolution. However, in this particular study, we decided to investigate refactoring. So this work was all about investigating how developers perform refactoring during code review. And we studied refactoring in 3 different aspects. First, we studied the intents that developers have, the goals, the reasons for why they do refactoring. We studied compositions of refactorings, and we studied the evolution of refactorings during code review. And all of these will be addressed in each of our research questions. To do this, we employed the CROP dataset. So CROP is an open source code review dataset that I created during my PhD, and it's today comprised of 11 software systems, almost 51,000 code reviews, and almost 150,000 revisions. And we chose all the Java systems on CROP, and for every single code review, for every single code change, we identified the changes in which refactoring operations are employed. So after selecting all of these changes, all the changes in which we could see refactoring operations, we asked a few research questions. The first research question was, what are common refactoring types employed for different intents? First, we had to identify the intents that developers have when employing refactoring during code review. For this, we analyzed every single code change with refactorings manually, and we identified from this manual process, we identified several different intents. For this presentation, I'm going to focus on only 3 that are more interesting. The first one is feature. So a feature intent means that that particular code change is regarding a new feature or a feature enhancement. So the developer is trying to implement a new feature or improve and enhancing an existing feature. Another interesting intent we called refactoring. The refactoring is a review, a code change in which the developer had the sole purpose of improving the system structure. Okay, so this is in these code changes, the developers, they were explicitly trying to improve the system internal structure. And we also had code changes in which we could see more than one intent. And the most interesting one was the feature refactoring intent, in which these are code changes that developers, they tried to both implement a new feature and refactor the system at the same time, right? And the most common case here that we found was developers, they start the code change to implement a feature, and along the way they notice that they can also improve the structure as a result of that change at the same time. So they sort of go on both directions. They have both goals for a certain code change. So to answer the question, we separated for reviews with different intents. We separated them by the type of refactorings that are applied in each of those. Here I'm listing only the top 5. So for instance, for reviews that implement new features, 42% of the time they apply extract method. 16% of the time they rename methods. These are the most common operations that they use. So these are the most common operations that developers use when implementing new features. When you consider the reviews, the changes, the code changes in which developers actually try to improve the system structure, we have something different. Although extract method and rename method are still the most popular, we have other reviews, other types of refactorings that are just as popular, such as move method. Also, a few refactoring types that were not employed much in feature changes are employed in refactoring changes. And when we consider feature refactoring, it's very similar to the refactoring column. So here we can see that when developers have the explicit intent of improving the system structure, they tend to use a more even distribution of refactoring types throughout that code change. The second research question was, how do developers compose refactory sequences to support their intents? So in our case, we consider a refactoring composition as a sequence of refactories in a certain code change. So we know that during code review, a revision is a code change is made of several revisions. So we consider a refactory composition as a sequence of refactorings that happen during a certain code change. And each composition, we classify them into 4 different categories. So rename compositions are made of a sequence of refactorings that only rename elements. Intra-class means a sequence of refactorings that only affect a single class, only the elements inside that class. A motion category means a sequence of refactorings in which the developers moved elements between classes and packages. And a hierarchical composition is composed of refactories that affect a hierarchy in the system. So, to answer this question, we identified how many of these different categories appear for different intents. So, for example, for the reviews that try to implement a new feature, there are no code changes that try to implement a new feature in which rename sequences are applied. So most of the time where developers try to implement new features, they use sequences regarding intra-class refactorings, right? So when we look at the refactoring category, most of the sequences are related to motion-related refactorings, and this is similar for the feature refactoring category as well. So this indicates that when developers are trying to improve the system structure explicitly, they tend to combine refactoring operations. They try to combine refactor operations that move elements between classes. And when developers are using refactorings to implement a new feature or in feature-related changes, most of the refactor operations are regarding a single class, are intra-class operations. So we conclude that different intents, they clearly indicate how developers compose refactory sequences. They choose and pick their refactor operations to support their particular intent. The third research question was, how do code changes with refactoring operations evolve during code review? So to do this, we classified each code change into 4 different categories regarding their refactorings evolution. The first category is same. In this category means that a certain change was created in the very first time with a set of refactorings, and these refactorings never changed. Throughout the whole history of that change, all the very same refactorings were present in all the revisions. In the added category, there is at least one refactoring operation that was added during a review. In the undone category, there is at least one refactoring operation that was removed from the code change during the evolution of that change. And in the both category, there are refactoring operations that were added and undone during the evolution of that code change. As a result, we found out that feature-related changes present higher volatility for refactoring operations. We noticed that in changes in which developers tried to implement new features or enhance existing features, there were a bigger presence of refactorings being added and removed and undone during the evolution of that change in code review. we also noticed that changes that only improve the system structure are, we found this one and done pattern where these changes commonly involve only a single revision or very few revisions, where the developer proposes a set of refactorings and they are accepted mostly as they are. There's no much discussion, and there's no much volatility in this case. So the implications of our work, what we believed we've done, we improved the understanding of the influence of intents on refactorings, on how the goals and reasons of developers influence how they refactor the system. We also notice that there is very little support for refactoring with specific intents. And also we notice that it's needed actually more automatic support for refactoring during code review. These are the major implications of our work. Hope you have enjoyed this talk. Thank you for staying until here. Bye bye.